Hello there. In this video, I want to talk about finding a 3 by 3 determinant. Now, you will need to know about row operations, the elementary row operations. So if you haven't watched that short, go ahead and do that really quickly. It's less than a minute. It shouldn't take you long. But I'm also kind of show you how to implement reduced row form. So, okay, when we're using elementary row operations to find the inverse of a matrix, we first should check the determinant. Now the determinant, if you watch my 3 by 3 determinant video, was -12. Okay, so -12 is our determinant. Remember, if it's 0, an inverse won't exist. This is not 0, so an inverse will exist. So the first thing I'm going to do is create an augmented matrix. And since I'm a little short on space here, I'm actually just going to erase this bracket. And I'm going to go ahead and put in the identity 3 by 3 matrix. So that'd be 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Now, the goal of this will be to create a matrix to use elementary row operations so that this ends up looking like this. Okay? Basically, get this identity matrix over to the left side, and then whatever winds up on the right side will be my inverse. That's the goal, okay? Actually, Okay, so how do you use elementary row operations? Well, again, I think the first starting point is always to get this to be a 1. Now, there's a couple ways I can do this. I'm going to go ahead and do it by multiplying row 1 by 1/2. So 2 times 1/2 would give me 1. But remember, this is an equation. It's just in matrix form. What we do to one side, we have to do to everything, okay? So how I write this out is I draw a little arrow. I'm going to write 1/2 times row 1. Okay, and I'll start my new matrix down here. So 2 times 1/2 is 1, 1/2 times 1/2 is 1/2, and then 3 times 1/2 is 3/2. And then I have to do it to my identity matrix, so I get 1/2, and then anything times 0 is 0. Okay, great. Okay, so let's go ahead and copy the other 2 rows because I didn't do anything to those. -1, 0, 2, 0, 1, 0, 5, 3, -1, 0, 0, 1. Now, if you're familiar with elementary row operations and how this process works, you might have been thinking of a different first step, and along the way you might think of different steps, and that's perfectly okay. That's okay to do. We want to work on understanding that there are multiple ways to go about doing this. And in future videos, we'll work with the same matrix, and I'll show you how we could have used row operations differently. Okay, so the strategy I always like to take is to get this part of my identity matrix in first. So I've got the 1. Now I want to get this to be a 0. So this number needs to be a 0. So how I can do that is I notice that if I have a 1 in the first row and I have a -1, if I add those two together, 1 plus -1 gives me 0. Okay, so let's go ahead and take row 1 plus row 2. And now the arrow of where I'm placing it is indicating that I'm replacing this row. This is the specific row I'm working on, and above it I write the operation of what I'm doing. Okay, so because I'm only working on row 2, I can go ahead immediately and copy row 1 and 3 as it is. Okay, and then 1/2, 0, 0, and then 5, 3, and -1, and 0, 0, 1. So 1 plus -1 is 0. Great. 1/2 plus 0 is 1/2. And then 3/2 plus 2. Well, that'd be 3/2 plus 4/2. That gives me 7/2. Okay, and then we get 1/2 plus 0, that's 1/2. And then 0 plus 1 is 1. And then 0 plus 0 is 0. Okay, so working off this initial matrix, that's a check, that's a check. So I want to get this number to be 0. So working on this one right here. So elementary row operations, I can no longer just add 2 rows together. What I'm going to have to do is take row 1 and multiply it by 5 and either add it with a -5 or subtract it with a 5. So what I'm going to do is I prefer to always add. So I'm going to take -5 times row 1 plus row 3. And I'm working on row 3 now. Okay, so I will copy that down here. And again, I'm only working on row 3 right now, so I copy rows 1 and 2 down because those aren't changing at all. 7 halves, 1 half, 1 and 0. Okay, so we have a -5 times a 5. Or sorry, -5 plus a 5. That gives me 0. That's what I want there. That was the whole goal. The next part is I got to get the 1/2 times -5. That'd be -5 halves plus 3. So that's a -5 halves plus 6 halves. You're going to need to know some operations of fractions and be able to work quickly in your head to do this. So -5 halves plus 6 halves, that gives you 1/2. And then 3 halves times -5, that's -15 halves plus a -1. So that's a -15 halves plus a -2 halves. That's a -17 halves. Okay. 1/2 times a -5 plus 0 is -5 halves. And then we've got 0 times -5. So that's just 0, and then 0 plus 1 is 1. Okay. Okay, great. So let's go ahead and work on that 0. Now, I noticed that 1/2 minus 1/2 would get me the 0. We want to be careful though about that because if I do the 1 minus 0, I'm going to get a 1 in this position again, and I don't want that. I want that to stay a 0. But luckily, right below that, we have a 1/2 that we can use, and this won't hurt us because we got 0 minus 0 here. So here, I'm going to go ahead and do row 2 minus row 3 in the place of row 3. So again, row 3 is changing, rows 1 and 2 are not. So I'll write them out. 1, 1/2, 3 halves, 1/2, 0, 0, and then 0, 1/2, 7 halves, 1/2, 1, and 0. And now 0 minus 0, okay, that keeps a 0. That's what we want. And then we got the 1/2 minus 1/2. That's 0. Okay, great. And then we've got the 7 halves minus a -17 halves. So that'd be 7 halves plus 17 halves. That's 24 halves. That gives you 12. Okay. And then 1/2 minus a -5 halves. So that's 1/2 plus 5 halves. 6 halves is 3. And then you've got 1 minus 0 is 1. And then 0 minus 1 is -1. Okay, awesome. I'm going to go ahead and transfer this to a new page, and we will continue. 1. Okay, so now that we've taken care of this, and this, I always like to work in this initial L. So I'm going to take care of this 12 next. And the only way to really do that in an effective way without combining rows and changing either of these zeros is to multiply it by a scalar. So I'm going to take row 3 and I'm going to multiply it by 1/12. Okay. Once again, rows 1 and 2 are not changing. So 1, 1/2, 3 halves, 1/2, 0, 0, 0, 1/2, 7 halves, 1/2, 1, 0. And then because these are 0, we multiply by a scalar. We still get 0 in those places, and we get 1 there. Okay. So 3 over 12, that would be 1/4. 1 over 12 is just 1/12, and then we have a -1 over 12. So sorry, I had to squeeze that in. All right, so the next thing I want to work on, this 1/2. I want to work on this 1/2, and I want to get it to be 2. Well, once again, probably best case scenario is to use scalar multiplication. I can multiply 1/2 by 2 to get that 1 there. So 2 times row 2. So when I write out my new matrix, again, rows 1 and 3 now are not changing. So 1, 1/2, 3 halves, 1/2, 0, 0. And then I am writing 0, 0, 1, 1/4, 1/12, and negative 1/12. Okay, let's go ahead. So 0 times 2 is 0, 1/2 times 2 is 1, and then 7/2 times 2 is 7. 1/2 times 2 again is 1, and then I get 2 here, and then I get 0 here. Okay, now let's go ahead and work on this 7 here. Let's try to get that to be a 0. Now the best row I can use, because I don't want to change this 0, is I want to use the last row, okay? So I'm going to take row 2, and I'm going to take it, or I'm going to take row 3, I'm going to multiply it by negative 7, okay? And then I'm going to add row 2. So once again, row 1 is not changing. If you notice, I like to save row 1 for last. Once I get that initial 1, I like to save the rest of it for last. It's just easier that way. So 0 and 0. And then this isn't changing, 0, 0, 1, 1/4, 1/12, and negative 1/12. Okay, so 1 times negative 7 is negative 7 plus 7 is 0. Oh, and while we're at it, 0 times or plus 0 is 0. 0 plus 1 is 1. So there we go. We got 2 rows set. Okay, so 1/4 times negative 7, that's negative 7/4 plus an additional 1. That would be 4/4. So negative 7/4 plus 4/4 is negative 3/4. That's a lot of fourths. Okay, and then we've got 1/12 times negative 7, that's negative 7/12 plus the 2. So the 2 would be 24/12. So negative 7/12 plus 24/12, so that'd be 24 minus 7 would be 17/12. And then this would become a positive 7/12, but I'm adding 0, so it'd be a positive 7/12. And look, now I've got 2 rows set. Final thing is to get this to be 0 and this to be 0, and you can work on that in any which way. If you're going to work on this one first, then that's going to be working off row 2, and if you're going to do this one, it's going to be working off row 3. So again, I'll start with 1/2. We'll take, oh, nope, sorry, wrong row. So we'll take row 2 and we'll multiply it by negative 2, and we'll add it to row 1 to replace row 1. And I don't know, should I do both at once? No, I'll do one. I like to stick one at a time. It reduces the risk of miscalculation. So again, we're just changing row 1 now. So rows 2 and 3 stay the same. We got negative 3/4, 17/12, 7/12, 1/4, 1/12, and negative 1/12. Okay. Pause to check, make sure I'm all good at this stage. Yeah, I'm all good at this stage. Okay. So we got the negative 2. Oh, sorry, that should actually be negative 1/2. That is a mistake. I'm glad I caught it. Okay, so negative 1/2. There we go. So negative 1/2 plus 1/2, that's 0. And 0 plus 1 is 1, so we keep that. That's the power of zeros. And then we've got 0 plus 3/2, that's 3/2. Okay, and now we've got negative 3/4 times negative 1/2. That'd be a positive 3/8 plus a 1/2. So 1/2 would be 4/8 if we're looking for a common denominator. So 3/8 plus 4/8 is 7/8. Okay, and now we've got the 17/12 times negative 1/2, that's negative 17/24, but we're adding it to 0, so negative 17/24. And then same for the 7/2. 7/2 times negative 1/2 is negative 7/24, and we're adding it to 0, so negative 7/24. All right, final one. We're going to work on row 1. We're going to multiply it by negative 3/2, or specifically row 3, and then add it to row 1. So one more time, I will not change rows 2 or 3. 17 over 12, and 7 over 12. And this will be the last step. 1/12, negative 1/12. All right, so 0 plus 1 is 1, 0 plus 0 is 0. So then we have the negative 3/2 plus 3/2 is 0, and we have our identity matrix on the left side. That's how we know we're done. But we still got to calculate, the top row of the right side. So 1/4 times negative 3/2. Well, that would be negative 3/8, and I'm adding it to 7/8. So negative 3/8 plus 7/8 is 4/8, so that would simplify to be 1/2. Okay, next we got 1/12 times negative 3/2. Well, that would be negative 3 over 24, and I'll keep it not simplified because I'm adding it to a 24th. So negative 3 over 24 plus negative 17 over 24, that'd be negative 20 over 24. That simplifies to be negative 5/6. And then bear with me one more time. Negative 1/12 times negative 3/2, that'd be a positive 3/24 plus a negative 7/24. That's effectively 3 minus 7 is negative 4 over 24, and that gives us negative 1/6. And this would be our 3x3 inverse of the original matrix. If you want to, you can go ahead and check it by multiplying this 3x3 matrix by the original 3x3 matrix. And because we're multiplying inverses, we do it correctly if, when we multiply them correctly, we get the identity matrix in return. So if you like that video, go ahead and give it a thumbs up and subscribe to the channel. If you want to see more videos like this, please leave a comment in the comment section, and I will see you for the next one. Thanks for watching.